boys and girls, let's take a look at problem number 4. It says the blue color of the sky results from the scattering of sunlight by air molecules. The blue light has a frequency of about 7.65 times 10 to the 14th hertz. So that's new. Right? Frequency is new. And that's 7.65 times 10 to the 14th hertz. Remember, that's a per second, or second to the minus 1. They mean the same thing. All right. What is the wavelength? Well, from a previous problem, we learned that wavelength is equal to the speed of light divided by the frequency. All right. The speed of light is 3 times 10 to the 8th meters per second. The frequency, which was given to us in the problem, 7.65 times 10 to the 14th per second, or a hertz. All right, the per seconds cancel, and I'm left with meters. I will get 3.92 times 10 to the minus 7 meters. All right, now we do want to convert this to nanometers. According to the problem, they ask us for that. Again, how do we get from the base unit of meters down to nanometers? It's 9 jumps. We're going down the chart, so we want to add 9 to the exponent. So if we add 9 to the negative 7, we get lambda. It's 3.92 times 10 squared nanometers, which is 392 nanometers. If we take this out of scientific notation, right, we move the decimal point 2 places to the right. So instead of being between the 3 and the 9, we're going to move it 2 and just put it after the 2. It would be 392 nanometers. Would be the answer to 4A. Now 4B, we're asked to compute the energy in joules of a single photon of this light. Now, when we want to compute energy, we're going to use the equation E equals h nu. The energy of a photon of light is equal to Planck's constant, which we symbolize with h, times the frequency, right? Greek letter nu. And now the frequency was given to us right here, and so let's use that. E is equal to Planck's constant. Right? If you look up Planck's constant, it's 6.626 times 10 to the minus 34 joules times seconds. All right? Joules times seconds. And we're going to multiply that by the frequency, 7.65 times 10 to the 14th hertz, which is a per second. Right? We have seconds here and a per second here. These guys will cancel, and I'll be left just with units of joules. So E is equal to a certain number of joules. We just multiply this number by this number, and then round it to 3 sig digs, and we will get 5.07 times 10 to the minus 19 joules. That's the answer to part B of number 4.